So for this problem, we're looking at C5, and we're given this subspace here. So these are all the vectors that satisfy these relations. 6z1 equals z2, and z3 plus 2z4 plus 3z5. Oops, that's a typo. That's supposed to be is equal to 0. Okay, so this is the collection of all 5 tuples that satisfy a linear system of equations. So it will be a homogeneous linear system of equations. So it will give us a subspace for sure. So our first task is to find a basis of U. Okay, so the way I like to approach a problem like this is to look at a generic element. So if I've got some element of U, then that means that I can write it as something involving relations between the variables, right? So let's see. So the first relation says that Z2 is 6 times Z1. So if I call this one T, then the second one has to be 6T because it's 6 times Z1. Okay, there's no relations on Z3, so I'll give it some other variable. It can vary freely. Let's call it S. And then there's no immediate relation on Z4, so I'll call it R. But then the last one, so if we take this equation here and we rewrite it, it gives us an equation 3z5 equals minus R minus 2s. Wait, did I do that right? Yes. So it gives it's constrained in terms of the previous ones, right? Okay, so let's see. So so then that's going to be so if I divide through by 3 on both sides, I'll have minus 1/3 R minus 2/3 S. Wait, S for Z3, did I do that right? Oops. No, I got those switched. Whoops. Hold on. Yeah, I did that backwards. Okay. So this is S and this was R. So 1/3 S, 2/3 R. Okay, there we go. And then let's see. So now I'm going to pull these apart into their different components. So I've got the T component, which is 1, 6, and then there's no T's anywhere else. And then I've got the S component. So that's going to be 0, 0, 1, 0, and then I've got a minus 1/3 back here. And then I've got the R component, so that's showing up now in the fourth and minus 2/3 there at the end. Okay, so I can take my basis to be these guys right here. So I'll take this one here to be U1, and this one here to be U2, and this one here to be my U3, and then I get a basis. All right. Okay. And so then let's see. So what do I need now? So part B asks me to extend this to a basis for C5. So let's see. So now looking at what I've got right now, this one here shows me that the first two are constrained in some relationship together, and they don't show up in either of the other ones, right? So I need to allow them all to vary freely in order to get all of C5. So I'm going to add in W1 equal to, and if I have anything here where they don't appear in the ratio of 1 to 6, it will work. So I could just take 1 And now by combining W1, by combining W1 and U1, I can get the element, the vector that looks like 0, 0, 1, 0, 0, 0, right? And so now I've got like part of the standard basis. And now I just have to look and see what's going on with the other ones. So let's see. And so, by the way, alternatives for this one, I could also have chosen like 0, 1, 0, 0, 0 for the same reason. Or I could have chosen something like 1, 1, 0, 0, 0. It doesn't matter, just as long as the entries in the first two columns here do not appear in the ratio of 1 to 6. Okay. And let's see, and so I'm going to need another W2. And let's see, so now if I look at the next one here, for this one, these guys are constrained to always appear in the same ratio, so that the third coordinate is -3 times the fifth coordinate. So I need to take something that's got the third and fifth coordinate in any other ratio. So again, the simplest thing is probably I can just go 0, 0, 1, 0, 0. Okay. And so now by combining W2 and U2 together, I can do something like if I do this one and then I multiply it by -3, then I'm going to get 0, 0, 0, 0, 1. And then I can combine this guy with the one that I have up here, U3, in order to get that one. And now I know that I'm able to build the entire standard basis out of U1, U2, U3, W1, and W2. So I know that that's going to give me a basis for all of C5. Okay. And then the last thing, is to, let's see, to find W. So I just take W to be the span of those two things that I found in the previous step.